The purpose of today's discussion is to understand how surge control logic is implemented using the stage differential pressure boost versus differential pressure flow in engineering data. So let's start the discussion. This is a schematic of multi-stage compressor. So compressor takes suction from either process gas or atmosphere. Then we have multi-stage compressor. It is shown three-stage compressor. One IGB compressor stage 1, then stage 2 and stage 3, and it is anti-surge control valve which is coming to suction in case of process compression, or in case of air it should be vented to atmosphere. Then we have NRV and discharge valve, which then it is coming to system pressure. Since the logic is for the stage, so we have selected compressors 2 stage. So we have inlet pressure PT1, which is suction of a stage 2 compressor, and discharge of a stage 2 compressor is PT2. Then we have one flow measuring device installed at the suction of a stage 2 compressor. So surge control, that is DP flow versus stage TP boost. So PT1 is inlet pressure or suction pressure of compressor for this stage 2 compression. Range of PT1 is 0 to 5 bar gauge, PT2 is final discharge pressure, and range of PT2 is 0 to 10 bar gauge. PDT is differential pressure transmitter of FT. Range of PDT is 0 to 2500. There is a mistake here. Either it should be mmWc or it should be millibar, but let's stay in mmWc. PT1, PT2 and PT2 FT are connected through electrical signal to PLC or DCS. In addition to this, all other instrumentation and control valves are connected to PLC or DCS. Now converting, PT1, PT2 and PDT data engineering value. So differential pressure or DP boost is equal to final discharge pressure minus suction pressure. So differential pressure boost is equal to PT2 minus PT1 in bar gauge. Now we have data of DP flow and DP boost in engineering unit. Surge test of compressor is conducted for minimum 3 IGV position and maximum any number of points. Flow DP and DP boosts. In engineering, it is wrongly written raw data. It is engineering data are collected during the surge test in the field. And DP boost is drawn on x-axis, DP boost on x-axis, and DP flow in y-axis. So surge slope is equal to DP flow either in any unit. It in case of, for example, it is written as millibar upon DP boost in bar gauge. So it is a millibar and this is a bar. DP boost in bar, DP flow in millibar. Surge is calculated on average of surge test data, and let's say surge slope is coming as 3.6 millibar gauge upon bar gauge, and surge bias is 0. So graph will be like this. In this logic, in this control philosophy, surge bias is always 0. Surge control line is 3.6, which is bar gauge, millibar gauge upon bar gauge. Surge bias is 0. So let's say safety margin is on surge slope, which is 10%. So now surge safety margin is 3.6 into 10 by 100 is 0.36 millibar gauge upon bar gauge. So surge control slope is equal to surge slope plus surge safety margin. So surge control slope is equal to 3.6 plus 0.6, which is 3.96 millibar gauge upon bar gauge. But surge control bias is same as a surge bias with 0. So you see, surge control line is above the surge line. Operating point engineering unit DP boost is 10 bar and DP flow is 85 millibar gauge. So operating point that is for slope 85 by 10, which is 8.5 millibar by bar. So you can see this is the point. You can see 85 here and 10 is here. So this is the point, operating point, and which is safe. And operating slope, you can see, if you take the slope will be like this, which is more than this value. Slope of this point is more than this because it is 8.5. PID controller, proportional, integral and derivative control, develop in PLC or DCS. Input data is process value, PV and set point SSP. One controller output. Output of PID controller will give command to anti-surge control valve through 4 to 20 electrical signal to positioner of control anti-surge control valve to operate it. Process value PV, operating DP flow millibar into factor F upon operating boost bar gauge. The factor F is multiplied to make this number larger. Set point will be average of surge test data of DP flow millibar gauge upon DP boost bar gauge plus surge safety margin into same factor F to make it again larger. So factor F can be 1 to any positive value. Typically it can be 10, 100, 1000, etc. So PID logic, if PV is greater than SP, then anti-surge control valve will be closed. If PV is less than SP, the anti-surge control valve will be open, and if PV is equal to SP, anti-surge control valve will be in the last position. Anti-surge control valve operation. Let us assume operating DP boost is 10 bar gauge, operating DP flow is 85 millibar gauge, factor F it is selected as 10, it can be any number but in this test example it is selected as 10. So surge slope is 3.6 constant, 10% safety margin will is equal to 3.6 into 10 upon 100, which is 0.3 bar, which is equal to 0.36 millibar gauge upon bar gauge. Surge slope with safety margin is equal to 3.6 plus 0.36 is equal to 3.96 millibar gauge upon bar gauge. Set point will be 3.96 into F is equal to 3.96 into 10, which is 39.6, which is millibar gauge upon bar gauge. So operating slope is equal to operating DP flow upon operating DP. So operating slope will be 85 upon 10, 85 upon 10. Now process value will be operating flow into operating slope into F. So process value is equal to 85 is operating into factor F, same F here is also multiplied 10, here is also multiplied 10, so 85 bar gauge. So logic of PID will be, since PV that is 85 is greater than 39.6, PV is greater than SP, so anti-surge control valve will close. So if compressor operates above the surge line, it is safe and anti-surge valve will close. If operation is below the surge control line, it is not safe and anti-surge control valve will be open. So this is a safe zone for operation of the machine, and below this is not safe, it is unsafe, so anti-surge valve should open. So thank you. With this I have finished this lecture. Hope you will like this. If it is so, please subscribe my channel, like it and share it so that you will get the intimation of my video. See you in the next session. Till then, bye bye. Thank you.